I'm John Pimblett with Impact Makers. I've been working on data solutions primarily as an architect for, well, 20 plus years. Thanks for inviting us to present at this Tech It Yourself session. And I'm here with my colleague, Mason.
Yep. Thanks. Impact Makers, I'm the analytics services lead. I've been with the company for about 3 years and just really enjoy helping people to improve getting business value from their data solutions. So that's part of our talk today. And to introduce IM a little bit, we are a data and IT consulting firm based out of Richmond, Virginia. We've been around since 2006. And we offer full stack data capabilities from advisory all the way through engineering. And one very interesting thing about our company that a lot of us are just very proud of is that we are a social business. So we are a for-profit company that gives our profits to nonprofit partners. Just a little bit about us. And here we go.
Right. Why does this topic matter? Why does it matter now? I think everyone realizes that companies have access to analytics and analytic capabilities like never before, thanks to easy to provision technology. Data is everywhere. Innovation through new insights and data-driven products and services can drive businesses where previously there were high barriers to entry. And the available technology is more advanced than ever before. There continues to be big data, and it continues to get bigger. We've got one of the cliched quotes up here, actually several of them. I don't know how many of these are still current from when we pulled them, but suffice it to say, there's a lot of data out there, outside of our enterprises, our companies, as well as inside the companies. Our systems are throwing off more fine-grained data more frequently, and our analysts and users and business decision makers want to be able to base their decisions and gain insights from deeper and deeper history of data.
Yeah, and then the last point on why this topic matters, why we're here today is, there are just so many options, so many tools that are being thrown our way from the public and specialty clouds to so many different platforms as a service, S3, Redshift, Databricks, Azure Synapse, Azure Data Factory, the list goes on. And then additionally, within the past couple of years, there are these new AI packages and off-the-shelf algorithms that essentially, our businesses are being approached by all of these packages for specific business problem solutions. So there's an explosion of tools, and it's unwieldy. So how do you sift through this noise? How do you really get down to brass tacks and accelerate data-driven value when there's a lot of distraction? And as a data leader, that's one of the things that keeps me up at night. We know the value that data can bring to our organizations, and we want to help everybody. But at the end of the day, you can't invest in everything. You have to prioritize. You have to have a goals in mind so that you're not distracted by all this noise. And so one of the things that we really try to stay grounded with is making sure that you start off with your data strategy. Where is the data-driven value in your organization? And how does that drive you and provide a guiding North Star to really implement and execute these other data capabilities through architecture, your technology choices, the analytics and data science that you deliver, the data governance process that you invest in, all of that is really driven by this data strategy. And that's where we aim to start when we talk to folks about this. So, and once you have the data strategy, what's next?
So in your company, you yourself or some of your leaders may be saying things like, well, we picked a data science toolkit, or more likely 2 or 3 different toolkits. We're done, right? Or we're sending all our files into an Azure or a Google or an AWS cloud data lake. Isn't that enough? Or increasingly, we've just adopted the latest data warehouse platform, and everyone told us that that's got everything that we need, right? Well, no, it takes more than just a single system or toolkit or workbench or platform. It takes a system of systems, as well as the people and the processes to run that system of systems. So on our agenda today, we'll talk about the modern data ecosystem, which is another name for the system of systems of your data solutions. We'll dig into the data warehouse as the core of the data ecosystem, and we'll cover the importance of and some ideas on how to build your data warehouse incrementally in pursuit of that business value that you identified coming out of your data strategy work. So let's start by going on a quick tour of a modern data ecosystem. We'll start with the basics. You know you want to be data-driven. How do you do that? Well, it's come down to the primitives, basically. You need solutions that help you get your data, or the data you care about, store that data, process the data, and use the data. And your solutions, and there's going to be many, your solutions for these capabilities need to work together. They also need to be secure against attack and data loss. They need to be scalable because most companies plan to grow, and certainly your data volumes are growing. Your user base is probably going to grow. They also need to be supportable. We believe that ecosystems are most effective if you think about support. How will the ecosystem run, and who will support it when things go wrong, and things always go wrong. So always include your production support operations stakeholders as you architect and build out your ecosystem. So let's look at an example of a data ecosystem. We define a data ecosystem as being an integrated set of platforms, systems, and services used to acquire, manage, and gain value from data. Behind that definition, there's the getting of data, and the storing of data, and the processing of data, and the using of data. At the beginning, it's important to create an architecture that defines your destination, your target state, and then draw a roadmap of how to achieve that target state, how to reach that destination. The architecture can provide guardrails and guidelines to keep you on that road, keep your project work that oftentimes is happening across the company, many federated teams in some enterprises, but keep that project work building out the ecosystem aligned to your long-term destination. Okay, so the first area that we'll touch on in our walkthrough is getting the data. You can have data producers that are inside the walls of your company or outside. They may more traditionally provide the data into your ecosystem through file transfer. Newer ways of moving data include streaming the data to get it more quickly into your data ecosystem so that you can gain value from it. And then this production of data and the importing, ingesting of data can be one time or it can be recurring. Some of the technologies that are at play here, many of you are familiar with. For your streaming hub, Kafka or Amazon Kinesis are big players. For the managed file transfer or a bulk exchange hub, simple basic technologies like SFTP or the S3 API or corresponding APIs for file and object movement for Google and Microsoft Azure. Also, third-party solutions like Dropbox or some of the traditional vendors, the IBMs or Progress Software, have managed file transfer suites that support that capability. Next, we'll talk about storing the data. Two main concepts here of data lake and data warehouse. There are many other ways or data architecture patterns for data storage that we aren't covering here, such as for low latency data storage using various NoSQL technologies or caching. What we are interested in, though, is managing the data of the enterprise in this ecosystem, protecting it, and then optimizing it, storing it in ways that it'll be more useful and more understandable. And some of the common technologies for data stores include Amazon Redshift, Snowflake and the Snowflake data platform, Oracle and SQL Server as legacy solutions. I shouldn't just say legacy, they have plenty of new cutting edge technologies, both in data center and in cloud. Azure Synapse is another useful technology for your data warehouses. Data lake technologies include Cloudera Data Platform, Azure Data Lake, Databricks Delta Lake. You also can do a homegrown data lake. Okay. And then processing the data, making the data more fit for use, changing its structure typically. Some of our examples of data applications include just that kind of data refinement application, what in the past you may have thought of as an ETL application. The more cutting edge event processing applications that can be triggered when events show up in a stream hub and can take an action and may put that action back onto the stream hub. The higher value scoring and segmentation types of applications coming out of your data science and machine learning work. And then some of the basic blocking and tackling of managing your reference data and mastering your data for use in the data ecosystem as well as outside the data ecosystem. There's a range of technologies supporting processing the data, supporting these refinement, enrichment, and mastering processes. For general purpose needs, Spark and NiFi, third-party tools like Informatica and Talend for data refinement and even for event processing. And then moving into the scoring, segmentation, machine learning, artificial intelligence, there are numerous tools, including bring your own toolkit, but Amazon SageMaker can help there. There are quite a few specialized fit-for-purpose engines to support your data applications. And then into the MDM, master data management, reference data management, there are also off-the-shelf tools, such as from Informatica and IBM, to help with those.
All right, so we've done 80% of the work through our getting the data, storing it, processing it, and now we want to actually garner insights. We want to use the data. We want to interact with our business and provide them with, potentially up to the minute insights for them to be making better decisions. And so with that, exploring the possibilities and enabling a lot of experimentation and test and learn approaches is, a big focus here. Also, promotion of user code to run those test and learn apps as productionized models is also a big focus that we've seen, and a shift to make sure that we have the ability to promote insights into more productionized applications. And that's the flow of information out of interaction and insight through data trustification to those data applications, which you can see coming out of interaction and insight there. Some of the technologies that play in this space in information delivery, you know, the visualization tools that we've all heard, Tableau, Power BI, ThoughtSpot, you know, we are inundated with the visualization capabilities now, not simple tabular reports of old. And then, of course, on interaction and insight, some of the data application tools also apply here. So R and Python, SageMaker, as John mentioned, TensorFlow, and of course our Jupyter notebooks that our data scientists are so enamored with.
So let's talk about some insights across the data ecosystem. First, just at the high level for the entire ecosystem, we believe that for most enterprises, public cloud is the ideal location for your data ecosystem. Digging deeper than that, various platform as a service products, including data warehouse as a service, offer additional benefits and reduced maintenance. Public cloud offers scalable, pay for what you use compute, nearly limitless storage of many different flavors, and almost countless managed services that can reduce your administrative overhead, sometimes to zero. Having a separation of storage and compute that is natural in all of the public cloud platforms also can greatly reduce costs in your data ecosystem and your ability to burst your compute power when you need it. In traditional data ecosystems and data platforms running in a data center, your storage and your compute were tightly coupled. You had to add more hardware when you needed to have more compute power, even if your storage was sufficient. You also had to struggle with resource management on shared hardware. And this continues to be challenging for any architecture where many users with many different workloads are sharing the same instance, the same compute power. Separating the storage and compute means you don't have to plan for your capacity ahead of time. Again, you can elastically make your compute available and then pull the data into that compute. So we'll talk a little bit about data exchange and fast data opportunities. Point-to-point transfers of data from your data producers as well as to your data consumers outside your data ecosystem are harder to support and inefficient. If you instead use one or a couple of centralized data exchange mediators, you get more reliable data transfers. You can engineer these mediator platforms for high availability and then scale them for throughput and performance. Your operations or production support teams have one place to go to support the jobs. Instead of having SFTPs running on several servers across the enterprise, each with different standards, you've got a central place for exchange of your data. Your logging and your monitoring is also standardized and centralized. I mentioned already there are several off-the-shelf solutions for both a streaming hub as well as for managed file transfer. These, as an added value, include connectors for commonly used data sources and targets. So Kafka is an example of that, particularly if you go with a third-party flavor of Kafka. You can use their Confluent's built-in connectors to cloud storage, to common database management systems, API interfaces to software as a service systems such as Snowflake. So you get a lot of lift by going with this central mediation pattern for your data exchange. Streaming also supports fast data use cases, and that opens up a whole world of new value opportunities. Once you break out of that bulk or batch, daily or hourly way of thinking, you can move into new value propositions and support new business processes. Speaking briefly about data privacy, if yours is an enterprise that is governed by any of the privacy regulations, including CCPA or GDPR or any of the many others, you're going to need to address that across your entire ecosystem. You likely are going to need to have a way to classify your data assets. You need to have fine-grained identity and access management. You need to show how you're encrypting, keeping that data safe at rest. You may choose a tokenization solution to obfuscate or replace the data at the edge of the ecosystem. It's definitely more challenging to retrofit an existing data ecosystem for privacy control. So if you know you're in scope for any of these regulations or you expect to be, then it is critical to build your privacy controls into the ecosystem from the start. I mentioned the tokenization. Some enterprises have had good success with not storing personally identifiable information in their data ecosystem, but rather at the edge, replace the PII, the name, the address, the social security number, the phone numbers, replace those sensitive attributes with non-sensitive tokens or surrogates, and then just carry that non-sensitive data inside the ecosystem. And then again, detokenize that on the way out if a data consumer needs to see the sensitive data.
So on governance, just like privacy, governance is something that's going to go across your entire ecosystem. And governance will look different for each organization. Focusing on, a minimal viable product with governance may end up looking like simple business glossary or adding data context to your technical assets. That way you are injecting that into a development cycle and not having those be an afterthought. That is one way that we've found success in helping to set up data governance within an ecosystem. And really, that MVP style will keep you from overdoing the data governance organizational design. So more of a bottom-up and top-down approach can really align to ensure that you're not boiling the ocean with your data governance efforts. So on information delivery, interaction, and insight, I alluded to this a little bit in the using of the data, but the tool sets are not just about that traditional reporting anymore. It really is visualization is the new way. It's table stakes. The business doesn't want to only see paginated reports any longer. And then also a growth in the self-service by the business consumers. This is a great opportunity for us in our industry to really enable new people, new users, and give them the power to understand and get insights from their data without help of IT. But with that comes some challenges as well. So, IT teams have to think a little bit further up front about managing the balance between information sharing and risk, and making sure that you protect the key risks. Many times that will be around your sensitive data, your PII, et cetera, and really enabling information sharing while managing and protecting that is a balance that needs to be managed carefully. And then lastly, in your analytical workbenches for data scientists, this is, again, table stakes. Enabling them to be independent, to use more open source tool sets, many different libraries. The mantra of control is decreasing for sure in this area. So it becomes more about innovation and enabling that innovation in these various ways.
Right, of all the pieces of the modern data ecosystem, the data stores are most important because it's all about the data. You might have data movement, data exchange jobs that are all point-to-point and they're hard to support and unreliable. Your reporting tool could be a 20th century technology, no fancy visualizations. You may have a data science workbench with a bunch of tools that don't interoperate. But if your data is well managed, if you've architected and you're populating your data stores and the data is well managed and it's stored in ways that make it understandable, make it useful, then you're going to likely be successful, even if all those other things aren't so great. But on the other hand, if you don't get those data stores right, it doesn't matter what tools you have and how well they work together. It's not going to make up for not having the data right. And of course, we show that you've got two areas within data stores of you can have a data lake, you can have a data warehouse. We think the data warehouse is more valuable. We do believe there's a place for the lake and the warehouse in the data ecosystem. But we wonder, maybe as the sun set on the data lake, maybe not yet, maybe it'll never set on the data lake, but it is late afternoon. The data warehouse just provides a better core for the data ecosystem for most enterprises. One reason for this is that lakes and warehouses naturally support very different grains of work. Data lake, in its simple architecture, and from the beginning, data lakes were meant to be simple. You can put and get files or objects of data containing many records. You can set your permissions for access at that file level, or more frequently at a directory level, directory having many hundreds, thousands, hundreds of thousands of files. This is true whether you're in an object store like S3 and you have virtual directories set with your S3 prefixes, or whether you're in more traditional storage and you have a file system defined over your data, over your files. You also, with a data lake, can delete files. Some technologies let you rename files, but you can delete them. You could move them to a different storage layer, such as an archive layer. But that's the grain of work that you would do in a data lake. It's at that file or object level. Again, the file or the object has a lot of data inside of it, usually about the same entity, but many, many records. A data warehouse, though, natively is going to support inserting and updating record-level data. You can find specific records by key, right? We're all familiar with this if we've used a data warehouse or really any SQL database. I can look someone up by an identifier. I can find a specific product, a specific transaction. Also, a data warehouse natively supports setting access control permissions at the table or column or even row level. Column and row level may be native, or it may just be done through some clever views on top of your tables. Data warehouse also supports deleting records. as well as erasing cell values or obfuscating cell values. Now, in some enterprises, the data architect will choose to have an architecture where the data warehouse is insert only, and that's okay. But if that data warehouse needs to comply with a right to be forgotten regulation, say from GDPR or CCPA, well, you've got to have some way, if you have sensitive data in a record in a table in your warehouse, you need to hide that data or actually remove that data. So in extenuating circumstances, even in an insert-only warehouse, you may find yourself needing to delete or update records. Again, data warehouse technologies and a data warehouse architecture supports that record level and even cell level type of operation. You might be saying to yourself, oh, there's a lot of data lake vendors and data lake presentations that speak of doing a lot of those data warehouse types of activities, but in a data lake. And in my opinion, then you're no longer doing a data lake. You're doing what you call an enhanced data lake, or really you're trying to turn a simple data lake into a robust data warehouse. And we believe that trying to do that by bolting on and enhancing, by bolting on data warehouse features to a simple data lake, it's going to take, first of all, more resources than you bargained for. And second of all, why do that if there are already solutions out there, such as data warehouse platforms, that provide those capabilities? There is something that you have to watch out for, and any enterprise, any person can fall into this, and that's the sunk cost fallacy. You may start off thinking I have a simple data lake. You add a simple catalog for your data lake. Then you get a data privacy requirement that says you need to know file by file or data set by data set in your lake, where do you have and which fields or which bytes in those files contain sensitive data. You could enhance your data registry or data catalog on your data lake. Then you could add in fine-grained access controls based on the catalog. But there's a slippery slope there. You may find yourself 6 months down the road having turned your simple lake into a not so simple lake, and instead you might have been better off at the beginning just going with fit for purpose technology such as a data warehouse platform. So there's another way to think about this, and that's that the data warehouse can provide a stronger foundation for the core of your data ecosystem. If we think of a lake as being something like a house foundation that's built with field stones, and for hundreds of years, thousands of years, this is how foundations were built. You'd use rock or stone of many different sizes and shapes, and your foundation may start out okay, but over time, as the mortar starts to fail, your foundation can start to shift or crumble and require expensive repairs. A cinder block, concrete block, or concrete foundation is much more reliable. It uses uniform blocks, it's straight, it's level, it's consistent, and it acts in predictable ways. Engineers love that kind of thing. The same is true for the core of your data ecosystem. In a data warehouse, it's more naturally predictable than a data lake. You've got a built-in data dictionary, strong data typing, standardized storage, whereas again, a simple lake from the beginning was intended to accommodate many types of file formats and compression algorithms and layouts. And you didn't have a detailed data dictionary down to the field level for your data lake. Okay.
I'm going to skip that one and just address. So, you know, we recognize that some of you on the call might be thinking, hey, you know, the data warehouse, I thought the data warehouse was dead. You know, I've been doing data warehousing for 20 years and we just could not seem to get this right. Data warehouses sometimes require long development time. There can be refactoring for new or changed data sources. And sometimes your loading patterns become inefficient and lengthy because of all of the transformation and business logic in your ETL. And so with a Kimball-based data warehouse model, the initial business need can be a success, and as time goes on, that success starts to fade. And so one thing that we've come across is new approaches to data warehousing can enable you to be more agile and to be more iterative and less top-down than a traditional Kimball data warehouse, or a Kimball-only data warehouse is what I should say. And so with that, we really focus on our agile data warehousing and really trying to enable more iterative approaches to both delivering the business value and also delivering that nice, clean, structured, foundational data. So, you know, where we start again is back at the data strategy and starting with understanding where you're headed. Some examples here related to customer. If your organization is focused on improving customer retention, if that's a strategic initiative, you know, what are the data capabilities underneath that? And from that, you also build your use case backlog. Your use cases then help you determine the data that you will source into your warehouse. And this is how we kind of process in an agile methodology and build your backlog for agile data warehousing. So once you have those use cases in mind and you have identified the sources that are necessary to deliver those use cases, you can then look for clusters that will possibly satisfy many use cases at a time. Prioritizing the data sources, how you load, and iteratively building from there is kind of the key principles of this agile data warehousing idea or methodology. And you really are looking to not just inject new capabilities with agile data warehousing, but also an agile delivery process. So leveraging agile Scrum, et cetera, to help build this, that process is a key to success here.
So as Tara pointed out, traditional data warehousing has had a hard time handling agile delivery. And they build it piece by piece and change often based on your changing business conditions and your new use cases. Businesses that are static tend not to grow and tend not to last very long. The same is true of data warehouses. So we believe that different approaches are needed in order to handle agile delivery of data warehousing and incremental delivery of business value from that data. Data Vault is fit for this purpose. Data Vault is an approach that includes an architecture, a way of modeling, data modeling, and a methodology for delivery. Like most any data warehouse architecture, it's layered, which reduces complexity for your users and also enables your engineers and your platform managers to optimize different pieces. So your users are interacting with the business layer. Behind that is a base layer of raw data. You've got staging to support the load. Staging is typically temporary, ephemeral. The loading through a data vault approach is distinguished by the fact that you've got minimal, if any, cross-source dependencies. Traditionally, data warehouses often try to pick winners in the ETL layer. Which record is right, which record is wrong, which key is correct, which key is not correct. and then have a lot of job interdependencies. And when one source is delayed, other sources may not be able to load yet, and problems can cascade from that. In the Data Vault methodology, you load your source data pretty much independently and can do it in parallel right into your base layer. You keep your data full fidelity, you're not throwing anything out, and you have precise auditability with the Data Vault method. You know where your data came from and where it is in your raw data vault. Most importantly, it relies on just a handful of design patterns built around hubs, links, and satellite concepts. And these are oriented around business keys, which are largely, in most enterprises, slow to change. Those design patterns lend themselves to a high degree of automation during your delivery, code automation, code generation, because of the predictability of the designs. The designs are also naturally extensible. When a source changes, in a traditional warehouse, you oftentimes have to do disruptive refactoring. In the Data Vault approach, your raw data vault neatly, cleanly extends for new and changed sources. Your business layer is where the fun happens, and so you still need to do some transformation and aggregation into the business layer, but you're doing that on an as-needed basis, virtually or physically. And just real quickly, some of the example technologies that we've used and that are commonly used in Data Vault-based ecosystems today. You can get your data in fast with Kafka in a streaming hub. You can transfer your files into a staging area. Maybe it's a data lake stage using Amazon S3. With various Snowflake technologies, you can get that data quickly into your raw data vault or your base layer inside your data warehouse managed by Snowflake. Tools like Snowpipe and Snowflake Streams and Tasks help here. And again, a lot of that code can be automatically generated based on parameters about your source data and your target base layer designs. You can then continue to use Snowflake for virtual or physical business layer. Might choose dimensional designs for that business layer for ease of understanding. And then you can interact with the data from data science workbenches, such as with Spark technologies or R, and your data applications themselves doing the refinement, as well as possibly scoring and segmentation, can also be Spark-based. So, putting it all together, your strategy drives the identification of your business value and what's important to focus on. Your data ecosystem, well architected, aligns the technical components into a cohesive whole, a system of systems. Your data warehouse is at the core of your data ecosystem, and a data vault approach enables agile data warehouse delivery so that you can focus on the data that matters most and add more data as you go, or change what data you're going after based on your changed business needs. And then Data Vault lends itself, as I mentioned, to a higher degree of automation than other data warehouse approaches. You can, by deliberately capturing parameters about your source data, about your target data designs, generate a high amount of the code for loading the data, as well as generating the DDL to create your base layer tables. So your strategy plus your ecosystem, the Data Vault approach, a lot of automation means you get rapid and incremental delivery of business value, and ultimately a positive impact for your company and your customers and even your community. So with that, I think we wanted to have time for questions from participants.
Awesome. Thank you, guys. I actually do see a question. Based on your experience, what specific recommendations do you have regarding leveraging strong data governance to break data silos?
Sorry, and I do not have the.
It should be in.
Okay, yes, got it.
Can you see it?
So an important piece of this is knowing what you have. In some enterprises, it's still a project to figure out what data is stored in the different, if you have an ecosystem or if you don't yet have an ecosystem, what data is in this data warehouse and that database and this data lake and that data hub. So having an accurate inventory that's automatically populated and that then is queryable by your users or your data stewards is a key to breaking down some of those data silos. So that you can see where you've got data redundantly stored. You also can possibly see that, well, you're storing the same data, but you've named things differently. And that's a recipe for disaster, for getting different results when you attempt to build machine learning models or do visualizations. Sarah, I don't know if you have something to add on the breaking down silos.
Yeah, I would just add, on the organizational change side, using data governance working groups or leadership can help to change the mindset from a siloed approach to more of an information sharing approach. And that doesn't happen overnight. That might include potentially policies, updated policies, new processes, etc. But sometimes the silos are more ingrained in history than real business needs, if that makes sense.
Awesome. I see another question in the chat box. Where is the best way to start with a metadata catalog?
Another DG question. Do you want to start off?
Well, I would say, but before you pull out your checkbook or credit card, you need to start with what your needs are. You might find that a simple spreadsheet-based catalog at the beginning, or a simple a simple SQL Server database or some relational database where you can capture and store and query an inventory of what data you have may be a good way to start. If you already have, though, a metadata catalog tool, I believe that the best place to start is with the physical inventory, what exists. And that's sort of your structure on which you can then start to overlay additional context. Business definitions, quality measures, comments from your community of users. So if I'll stop there and see if Tara has something to add.
Yeah, starting small, I think, to John's point, is one key. Also, taking advantage of some of the tools that have the capability to upload basic information from your data stores can help get a lift in the effort it involves to get started. So some of the SaaS catalogs can actually take the information out of, say, a SQL relational database, and then you have your inventory started. Then setting out some of the key metadata aspects that businesses need to chime in on would be the next step. So technical metadata first, then adding that business glossary aspect to it would be one way that we've had some success in the past.
Awesome. Another question. Do your ecosystem recommendations and warehouse versus lake apply for unstructured data as well, or are there differences?
Sure, that that deserves its own hour. So I think the first question goes to what is unstructured data. If yours is a business that needs to and would benefit from analyzing, let's say, audio or video or image data, then you're probably not going to store and analyze and parse that complex unstructured data in a data warehouse. If you kind of move a little bit on the spectrum into what is sometimes called semi-structured or variably structured data, maybe this is coming from social media sources or even from systems inside your organization, but it's data that's formatted with JSON or XML or other ways of formatting data that's more flexible and less rigid than tables and rows and columns. That data, in order to interact with it, sometimes needs to be enriched and enhanced and transformed into a tabular format. And traditionally, you would do that in your ETL layer and then put it in your data warehouse. Newer data warehouse platforms actually welcome the semi-structured data, and they have features to let you not only store JSON and XML data, but to run queries against it. Again, in your architecture, you might still choose to pull out of the semi-structured JSON or XML what you care most about and possibly integrate it with other data and store it into a traditional table. So I think maybe behind this question, though, was, isn't that still a place for a lake? Absolutely. A lake is basically a file store with ability to do some compute, to interact with the data in certain ways. And anything can go into a file store. Your spreadsheets and your PowerPoints and your images and your audio and your comma-separated flat files. It can all go into a data lake, but it's oftentimes all stored in different ways. You don't have that idea of a common, consistent foundation that's easier to work with.
Okay, we got questions coming in left and right. All right, everyone, when is the best time to get the business involved in a data ecosystem implementation?
That's a softball. Early and often. Even to the point of you don't want to go off and provision all the parts of a data ecosystem without first having worked with the business to say, do they even need that part? Do they have streaming use cases in hand, for example? So do you need to provision a streaming hub? Do they have a lot of unstructured sources of data or need to get at a lot of unstructured data? If so, you better provision a data lake to handle all of that. But often you've always got to true back to what matters to them. No science experiments, right? Most enterprises don't have the resources to do this just to do it. You're doing it to have impact within your business and for your customers.
Yeah, early and often, and standing up cross-functional teams that include the business users, often in an agile process, will help with that engagement. And that takes time too. Not every organization is ready for their business to get under the covers with the data team. But that's where we found a lot of good success, and it's fun interacting with those other folks as well as you're building out these capabilities, insights, etc.
Awesome. Okay, I think we have one more question. Any tips for keeping costs under control in a cloud-native data ecosystem? Looking at your diagrams, I can envision a lot of areas where costs could creep up. Great
question. So especially in a cloud native ecosystem, right? So take advantage of the separated storage and compute. Storage is cheap. Compute is where your costs tend to really go up. Monitor obsessively. Monitor what's going on. When you're dealing with ephemeral or elastic compute, especially if you're dealing with self-service compute, where your end users or your application owners can call up, right? Can start up as much compute as they choose to, but then maybe need to be responsible for shutting it off. Obsessively log everything that's going on at the infrastructure layer and the service layer, and essentially do analysis on that, do monitoring on that, do alerting on that. So that's one way just to see when the costs are running out of control. Some of the technologies that we like have ways built in basically to keep costs lower. Snowflake, for example, is natively separated storage and compute. You do pay to get your data into a Snowflake database. You pay just the essentially cloud provider list price for storage, right? The street price for S3 or the street price for Azure Blob Storage. But if you're not doing anything for an hour, you pay nothing for compute. That's very different from a traditional data warehouse or even a cloud-based warehouse like a Redshift, where you need to provision that service and you're paying by the day or by the week, by the month for it. In Snowflake, you'll pay by the compute you use, and you can turn compute off when there's nothing happening, or you can turn it off by schedule. So yeah, don't keep your expensive compute always on. Turn it on and off, either manually or with your own scripts, or naturally natively in some of the managed services. Is there any other thoughts on cost?
Awesome. Well, we are almost right at 1 o'clock. Thank you guys so much. This was fantastic. I put both Tara and John's LinkedIn profiles in the chat box if you would like to connect with either of them. Other than that, everyone have a great rest of your week. Thank you guys.
Thanks so much, everybody.